right, in this video we're going to talk about some applications of angles. Now, beyond trigonometry, beyond sines and cosines and tangents, angles can be used directly in a few different formulas. One of those formulas is arc length. So you'll notice up top here we've got the arc length of an arc is equal to S equals R theta. The radius multiplied by the radians, or the angle measure. So you'll notice over here at the left we've got a circle. It's got a radius of 12, right? So we know that R would equal 12. And we know that it's got a central angle, as we say, the angle between the lines, right? From A to B is 45 degrees. Now notice in the formula we said it's got to be in radians. So the first thing I need to do is convert 45 degrees, right, times pi over 180 into radians. And you might remember that 45 over 180 is really 1/4, or basically 45 degrees is pi over 4. So then all we need to do to find the arc length S is take the radius, 12, times the radians, pi over 4. So let's go ahead and hop on our calculator real quick, and we'll do that. So I'm going to clear out what I previously had on there, and we're just going to multiply 12 times pi divided by 4, or basically 3 pi equal to 9.425, right? 9.425. And again, we didn't have an angle measurement, so we would just call that units, right? I apologize for the handwriting there. But 9.425. A bike tire has a 24-inch diameter. Well, the first thing we want to remember is, again, in our formula, we need the radius. So if 24 is the diameter, we're going to call that 12, similar to our circle up top there. For the radius, how far does the bike travel in 15 rotations? Well, now the same idea we did up top. We had degrees before and we needed radians. Right now we have rotations and we need radians. Well, 15 rotations, right? Well, there's one rotation in every 2 pi radians, right? One full circle. So what I would say is our actual angle is 30 pi. One rotation would be 2 pi. 15 rotations is 15 times that, or 30 pi. So to find the arc length, or the length around the tire, right, traveling around 15 times, right, as the tire rotates 15 times, we can say that we have the radius, 12, times the radians, 30 pi, right, radians to travel around that circle 15 times, which basically would become 360 pi. And since we're talking real world, let's go ahead and find that number. 360 times pi. And we've got 1130,973. So we're going to say that's equal to 1130.973. And now this time we were talking with an actual measurement. So what we're going to say is that's 1,130.973 inches. And it'd be your prerogative if you want to convert that, into feet or miles or whatever else you want to measure in. Feet might be a slightly better measurement, but we're just going to go with inches on there. A couple of other formulas that we can use directly with angles are angular speed and linear velocity. All right, so talking about speeds or velocities here. The angular speed is essentially the angle you travel through over time. Think of a rate. Think of things like linear velocity as things like miles per hour, right? Well, angular speed would be things like angle per hour, or angle per minute, or degrees per minute, things like that, radians over time. So how fast does the second hand travel around a clock in radians per minute, right? Well, the second hand, right, if we're talking about radians per minute, well, the second hand's going to make one full rotation, again, in 2 pi radians, right? That would be 2 pi. And we know that the second hand goes 2 pi radians, right, in 60 seconds. But also, it would go 2 pi radians in 1 full minute, right? So basically, we're going to go 2 pi radians per minute. Just that simple. It's going to make one rotation, right? Every minute. So that was kind of an easy one there. But notice that we divided our radians by our time, right? By our minutes, very simply. Linear velocity, well, an ant has taken a ride on that second hand 3 inches from the center of the clock. How fast is it traveling in inches per minute? Right? In inches per minute. Well, RW, or basically the radians over time, right? Or W equals, I should say, radians over time. Basically, that W shape, that W, was our angular speed. And since we know that the second hand travels 2 pi, right, radians every minute, we can just take that multiplied by our radius, right? He's riding 3 inches from the center of the clock, and it would be essentially 6 pi, right, inches per minute. Sounds like a pretty good answer to me. Basically, just take your radius times your theta divided by t, right? Radius times angular speed. Radius times theta over t. So another way to write that formula might just be better to say radius times theta over, not W, over t, which you might recognize as the arc length, right? The distance, arc length over time, right? Isn't length over time velocity, right? Distance over time also makes sense. Finally, another easy formula to use with just angles, right, is the sector area. A lawn sprinkler sprays 80-degree sectors, or an 80-degree sector of a lawn. It reaches 10 feet. Well, if we kind of imagine that, right, it's going to spray out 10 feet, and it's going to reach an arc, right, of 80 degrees. What we want to know is what portion of that lawn, right, is it going to cover? Well, our simple formula is area of a sector equals 1/2 r squared theta. And if theta is in radians, first thing I need to do then is convert my 80 degrees, right, times pi over 180, or basically, if I cancel those zeros, 8 over 18, or 4/9 of pi. So now I can say A equals 1/2 times the radius squared, so 10 squared, times my radians, 4 pi over 9, and we can simply find our area, right? So half of 100 would be 50, and 50 times 4 pi over 9, well, let's go ahead and find that. 50 times 4 pi divided by 9, and we've got 69.813, right? And again, now we're talking about area, so this would be square feet, right? That would be square feet. I hope that helps you with the different various formulas you can use with radians. If you have any questions, talk to your teacher. Make sure to get to know those formulas: sector area, linear and angular speed, and also arc length, a fairly simple formula. Have a great day.